Differentiation with the power rule is one of the easier tasks, I would say, in math. And the way it works is this. Can you see it? So we have a function which is 3 times x to the power of 2, and we want to differentiate. And the way it works is you look at the 2, and you have to put the 2 like at this place, so that you have 3 times 2, so the 2 becomes a factor, right? And the second step is you have to subtract 1 of the power. So we get 3 times 1 times x to the power of 2 minus 1. This is the rule. This is how it works in principle. So as I said, you take the 2 goes here, becomes a factor, and you have to subtract 1 from the power, right? It's not too complicated, and I would say this is also one of the easier rules when you want to differentiate. I will also demonstrate this with an example in the following clip. How to do differentiation with the power rule. It works the following. We have given a function which in this case which has a power, and when we differentiate, it works always like this. We multiply the power with the coefficient and we reduce the power by 1. So when we differentiate, as I just said, we multiply the power with the coefficient. 2 times 3 is 6, and we reduce the power by 1. 2 minus 1 is 1. And we can do that again. We can differentiate again, so we take the power, multiply the power with the coefficient, which is 6, and we reduce the power by 1. 1 minus 1 is 0. 6x to the power of 0 is 6. So this is how it works. It looks quite easy now, but it can be a little bit more difficult, and I will show you some examples about that. So let's just do another example. F is 5x to the power of 2, no, just a 5 instead of a 3, and the way it works, when we differentiate, we take the power, multiply with the coefficient. 2 times 5 is 10, subtract 1 of the power, so 10x to the power of 1, or we can also omit the 1, of course. Then differentiate again, then we have 10x to the power of 0, but as I just showed, x to the power of 0 we can also omit. Then another differentiation would result in 10 differentiated, but this is not really power rule anymore. Then we end up with 0. And what we actually did, I can demonstrate it to you. So 5x to the power of 2 looks, I bet it looks something similar like this, a parabola, right? The first derivation, how does it work? So parabola, this would be f. So we have negative slope, very negative here, and the slope becomes less negative until here. Slope is 0. Slope is positive then suddenly. It starts with a little bit positive and gets more and more positive. So the way it looks like, probably something, so as we said, negative, very negative, and then 0, and then positive, and more positive. So the way it looks is this. So this is the first derivation, the term we just had. Second derivation then looks like slope, positive slope, and the slope is always the same actually. It doesn't really increase, decrease, the slope is always the same of f, of the first derivation of f. So it is positive. It will probably look something like this. And when we differentiate again, you may already know it, when you differentiate again, the slope is 0, so it will be right on the x-axis. Right, second derivation and third derivation. We don't see it anymore because it's on the x-axis. So now let's just calculate another example, a little bit more difficult than the previous ones. 2x to the power of square root 7. Now the power looks a little bit strange now, looks ugly, but we can differentiate it without big problems. So first derivation, as I just said, we take the power, multiply with the coefficient, 2 times the square root of 7x, and we subtract 1. Then we can differentiate again. As I just said, we leave the coefficient, we multiply it with the power, which is the square root of 7 minus 1, then x, and we subtract 1 again. 1 minus 1, minus 1 is minus 2. And we can, if you want, you can write it a little bit nicer. So we multiply it, which would be 2. This multiplied with this would be 7. 2 times 7 is 14. 14 minus, and then 1 times this expression is 2 square root 7. And this multiplied with the term at the end, which is square root of 7 minus 2. So we can calculate another example, but you see it's always the same. We subtract 1, or first we multiply the power with the coefficient, and then we subtract 1, or we reduce the power by 1. Another example, last example, function minus 5x to the power of 23. And the way it works, just as before, we multiply minus 5 with the power. So in this case, 5 times 20 we know is 100, 5 times 3 is 15, so it's minus 115. X reduced by 1 is 22 to the power of 22. Then we can differentiate again. Then it looks a little bit more ugly. Then we better take the calculator, so we have minus 115 times 22, which is minus 2,530. Minus 2,530 x to the power of 21, because we subtract 1 of the power. And we could now go on and differentiate again and again and again until we're out of the power. But it always works the same, right? So just take the power, multiply the power with the coefficient. The coefficient is the number before the x, in front of the x. Then finally reduce the power by 1. This is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheeps.com.